Hello, everybody. In this short little segment, we'll talk about the perception of loudness. Let me remind you that studying the perception of sound is quite different from studying sound as a physical phenomenon. So physically, sound are pressure waves, longitudinal pressure waves in the air. And we've talked about physical characteristics like the intensity, how many joules per second a sound wave delivers per unit area, right? Watts per square meter. And we talked about decibels, which is just related to the intensity by a transformation through a logarithm. But what about the perception of sound? It turns out that the ear is not equally sensitive to all frequencies, and that makes things pretty complicated. In particular, in order to perceive the same loudness for sounds of different frequencies, in general, the sounds must have different intensities. So if you have a sound of a fixed intensity, but you change its pitch, you're not going to perceive it at the same loudness. In order to perceive the same loudness, you generally have to have different intensities for different frequencies. Okay, up till now, we've been using decibels, sound level in decibels, as a good proxy for loudness of a sound. And that works quite well at 1,000 hertz, as you'll see shortly. So 1,000 hertz is sort of the reference frequency. Where's 1,000 hertz, by the way? It's in between this B and this C on a standard keyboard, piano keyboard. Right, this B is 987.7, that C is 1,046. Somewhere in between there is 1,000 hertz. Okay, well, loudness, the loudness level is measured in fons, and we'll see that's key, defined in terms of 1,000 hertz. Sound levels in decibels, loudness level is measured in fons. Okay, human ear is not equally sensitive to all frequencies, so we have this graph, which is a little complicated, so let's go through it. On the x-axis, we have frequency. It's on a logarithmic scale, but never mind, it's frequency. And vertically, we've got the sound level in decibels on the left, and on the right, we have the intensity. So remember that, it's 1-to-1. Sound level is related to the intensity just by that logarithm transformation. So 60 decibels is always 10 to the minus 6 watts per square meter of intensity. And now we have these curves. So let's pay attention to, say, this spot right here. Actually, let's pay attention to 1,000 hertz. And notice that the numbers here correspond to the sound level where that red curve intersects 1,000 hertz. Right, so we have 0 here, we have 20 here, we have 40 here, 60, 80, etc. These are the fons. So these are the units of perceived loudness. And so at 1,000 hertz, the perceived loudness in fons is exactly the same as the sound level in decibels. So the proxy is perfect by definition. That's what we were talking about before. We were using decibels to indicate loudness, but it really only does so at 1,000 hertz of sound. Now, what is the meaning of these curves? Well, the curves correspond to equal perceived loudness. So let's take a sound of 1,000 hertz at 40 fons, which means that we're talking about 40 decibels of sound. And let's compare that to a sound at 100 hertz, so a lower frequency. In order to perceive the same loudness, the sound at 100 hertz has to be a 60 decibel sound, a more intense sound. Let me say that again. Suppose you're listening to a sound at 1,000 hertz and 40 decibels. That's a certain level of loudness that you perceive. And now let's say that you're listening to another sound at 100 hertz, lower pitch. In order for that second sound at 100 hertz to sound equally loud as the 1,000 hertz one, you have to dial up the intensity up to 60 decibels. That's the meaning of this red curve. This is all perceived the same loudness level. So you see that loudness depends on frequency and intensity. So here it is in typed words. The curve labeled 40 fons, that's the one I've been paying attention to, represents sounds that are heard by an average person to have the same loudness as a 1,000 hertz sound with a sound level of 40 decibels. And that's where the 40 fons comes from. If a person hears a 100 hertz sound, it's over here, it would have to have a sound level of 62 decibels to be perceived as being just as loud as the sound over here at 1,000 hertz and 40 decibels. Okay, so that's a little complicated. So with a little thought, you can study this graph and see what it means. Just remember that the red lines correspond to equal perceived loudness. Okay, so that's it. I'm not going to test you on fons, so don't worry about that. I just wanted to explain the complications of perception of things. Next up, we'll do some example problems. See you in that one.